Before we move on to page 7 of section 8.6, let's go ahead and go over the logarithmic rules again. What I want you to notice is these are the exact same 7 rules that logs had. Let's see if I can find the page. Yep. So the very first page of our packet had these 7 rules, and the only difference was these were logs base b. Well, this is same rules, but logs base e. So you're not learning anything new in this next part of this section. You're just learning that no matter what the base of the log is, whether it's base 10 or base 6, or in this case base e, all the same rules and properties apply. So log of 1 is 0, as is natural log of 1 is 0. And the reason, if you remember right, there's an imaginary e here. And when we do loop and swoop, we get e to the 0th equals 1. And that's how we know that what we've written is true, because when we put it in exponential form by doing loop and swoop, we get a true statement. Anything to the 0th power is 1. So log of 1 is always 0. And you can do it on your calculator if you forget, because students go, I can't remember if it's 0 or 1. Well, do log of 1 on your calculator. It'll tell you it's 0. Do it. Natural log of 1 on your calculator, it will tell you it's 0. So don't ever guess. But you should be able to do your loop and swoop to see why. If you put 1 there, you would say e to the first is 1. Well, that's not a true statement. But when you put 0 there, e to the 0th is 1 is a true statement. So that's how you know you're correct. And here, remember, there's an imaginary e here. So when the base of the log and the base of the exponent are the same, they undo each other, and the answer is the exponent, which there isn't one there, so we can assume it's 1. Same thing here. We have an imaginary base e down here. So the base of the log is e, the base of the exponent is e, so our answer is just the exponent, which is p. So remember, these are the inverse properties of logarithms. Inverse meaning they undo each other, because the base of the log and the base of the exponent are the same. Inverse property of logs. And here, same thing. We have e is the base of the exponent. There's an imaginary e right here, so e is the base of the log, so they undo each other, and our answer is our argument, x. And just like what we did in the last section, when you have a product, it turns into addition, just like exponent rule. And it's kind of nice to always put the exponent rules here to remind you, oh yeah, in multiplication, we add our exponents. So the log of multiplication means add the logs. Quotient rule, x to the 5 divided by x to the 3rd. Keep the base the same, subtract the exponents. So the log of the quotient turns into subtraction of the logs. And then the power rule, as before, doesn't matter if it's a natural log or a log base e, or log base 10, or log base 6. The power just comes out in front and gets multiplied by the natural log or logarithm. So all the exact same rules we just learned in 8.5. So none of that's changed, which makes this section easy, because it's like, oh good, I'm not doing anything new. I'm just doing the same thing I've done before. Okay, let's move over to page 7 after that little review. I'll put my blank sheet in so I don't bleed through. Okay, so we're back to writing sum or difference of logs. Remember how that means expand. So 8a and b are just another way of saying expand the logarithms. Is right as a sum or difference. So you take one log and you're going to turn it into 3 or 4. One log and you're going to turn it into addition or subtraction of 3 or 4. And then down here, we're going back to the single logs. So this is the exact same thing we just did in 8.5, but now we're doing it with natural logs, but nothing's changed. So same rules. This is multiplication. So we learned that multiplication turns into a sum of logs. So natural log of 3 plus natural log of x. Division turns into subtraction. So we write minus natural log of e squared. So now we have to look to see if anything simplifies. E to the what is 3? No. That has a variable in it? No. But whoa, wait a minute here. Look at this. This one has an assumed base of e, and the base of the exponent's e, so the answer is just the exponent. So my final answer on this will be natural log of 3 plus natural log of x minus 2. Because remember, the answer is just the exponent because these two undo each other. So you just bring 2 down. So that would be my answer. So why don't you guys turn off the video and try B on your own. That way you can make sure you have this down. Okay, for B, we have multiplication again. So multiplication turns into a sum of logs. So natural log of x squared plus natural log of y. Division turns into subtraction. And remember, z, square root of z is really z to the 1/2. It just saves you a step later. Power over index, so that will be minus natural log of z to the 1/2. And notice I have to write the word log in front of each argument. So the natural log of x squared. Multiplication turns into addition. Natural log of y. Division turns into subtraction. Minus natural log of z to the 1/2. So they all have variables, so I know they can't be simplified, but I do have 2 power rules here. So the powers do have to be brought down before I call this my final answer. So 2 times the natural log of x plus that one, there's nothing to do, so just natural log of y minus 1/2 times the natural log of z. Now I'm done. So these all have variables. That's how I know they can't be simplified. There we have it. So on the next 2, we're going to do the opposite. So let's do the first one together, and then you guys can practice on the second one. So now they're asking us to write as a single logarithm. That means the word log is written once. So you can get it all ready here. Natural log written once. I can see there's subtraction, so I know there's going to be division. So just get the final answer just sitting there ready. So we can put the 1/4 up there. We can put the 2 up there because remember we have to do power rule first because now we're doing the opposite of the 2 we just did above. We did the power rule last on these because this was expanding. Now we're condensing, so we do the power rule first. I recognize this. Is this the same numbers we had on that other page? Kind of looks like it, huh? So natural log of 17 to the 1/4 minus the natural log of y squared. And this one already has its power there, so we just write natural log e to the x. But 2 things you should notice about this step. 1, we have a fractional exponent. Remember that produces radicals, so we go back into radical form. 2, anytime you see an e in a natural log, it can be simplified because the base is an e of the natural log and the base of this exponent is an e, so they undo each other. So this last term is just going to be the exponent, which is x. So this is going to turn into a radical. So natural log of 4th root of 17. So this is the index, this was the radicand, and this is the radicand's power, which is 1. Nothing we can do here because this is not a fractional exponent, so just leave it. and the last term just turns into x because these two bases undo each other and the answer is the exponent. So what I need you to realize is this is not part of the log anymore. There's no word log or natural log in front, so it immediately goes out here. It is not part of the whole log thing. It does not have a log left because these undid each other. The answer was just the exponent. So that's why it needs to stay outside. So you're done with that. We learned in the last section when the log is positive, that means its argument goes in the numerator. When the log is negative, just like when the exponent's negative, you have to bring the argument down to the denominator. So y squared goes down here. So that would be your final answer. So natural log of 4th root 17 divided by y squared minus x. So we wrote the natural log once. This no longer was part of the log scene, so it stayed outside the parentheses. And there's our answer. So I think you guys should try the next one. It's a lot easier than the one we just did. So I would try that one and make sure you got this down. Okay, so first thing we have to do are power rules. So we have 3 powers here. So all 3 powers need to go up. So the first term is going to turn into ln x cubed plus ln y to the 9th minus ln z to the 1/2. So right away, things that are drawing my attention, fractional exponent, that needs to be a radical. So ln x cubed, nothing I can do there because there's a variable, there's no e. Same thing here, nothing I can do here. There's a variable, no e in the argument, but this one I can turn into natural log of square root z. So here's the index, z's the radicand, 1 is z's power. And now I can go straight to my answer. So I write the word ln once because it says single logarithm. I put a division symbol because I see subtraction. I know the negatives go in the denominator. So the 2 positive logs, their arguments get multiplied in the numerator. And the negative, just like negative exponents go down, negative logs, their argument goes down in the denominator. And that would be my answer. So that was a pretty easy one, right? Okay, so we have about 1.5 minutes, just enough time to explain the change of base formula, and then we'll start the next page. So what if the base is an e or x, or excuse me, e or 10? If the base isn't 10 or e, I can't do it on the calculator. So somebody really smart came up with the change of base formula to make all bases e or 10. So what it says, and it's easier for me to explain with numbers. So let's say we have log base 6 of x. No, let's say 7. Okay, and somebody tells me to evaluate that. Well, in order to evaluate it, I can't have base 6. My calculator doesn't know base 6. But the change of base formula says you can do log of the argument divided by log of the base. And now, guess what? It's base 10. Is that so awesome? So I like to say log of the high divided by log of the low, low meaning number down low, not the smallest number. I can also write it with natural logs. Natural log of 7 divided by natural log of 6. So now I can plug both of those, either one, into the calculator and evaluate that log